In chemistry, you will do yourself a favor to consider density as a conversion factor. We start with an identity. For example, gold has a very high density. 19.32 grams of gold is equivalent to a milliliter of gold. So we can use this identity to write two conversion factors. We choose the factor we need based on the units that we want to cancel out. In this problem, we want to go between grams and mass, and we're given a value of density. So 4.54 grams per milliliter as a density translate to 4.54 grams is equivalent to a milliliter. So based on this identity, we can write two conversion factors. We're going to choose the conversion factor that cancels out the unit we don't want. We want to cancel out grams, so we choose the conversion factor that has grams in the denominator. So we see grams cancel out. The setup indicates that we use division. 163 divided by 4.54. We get our calculator answer. To worry about sig figs, 3, so we know our answer has to have 3 sig figs. And we get our final answer. In this problem, we're given a volume of a sample, and we want to calculate the mass. To accomplish this, we're going to use the density that we're given as a conversion factor. Given our identity, we can write two conversion factors. Start with a measured number from the statement question, and we need to cancel out units of milliliters, so we're going to choose the conversion factor that has milliliters in the denominator. Conversion factors imply equivalency. Saying we have 0.7910 grams is equivalent to saying we have a milliliter. We see that we've set up the problem correctly because units of milliliters cancel. We end up with units of grams. We do the math, which in this case is multiplication. Write down our calculator answer. We see here 3 sig figs, 4 sig figs. So we want 3 sig figs in our final answer, which means that we're going to have to round up. This next problem's more involved. We have a cube of gold that of a particular dimension. We're going to calculate the volume of that cube by multiplying the length times the width times the height. Once we have the volume, we can convert to mass using density, and then we can go from mass to moles using our formula weight. So we've calculated the volume of this cube. Since cubic centimeters are the same as milliliters, this also gives our volume in milliliters. Now we can go from volume to mass using our density, which we've looked up, and we can go from mass to moles using our formula weight. And here's that calculation. We've set things up so that units of milliliters cancel and units of grams cancel. So moles survives. And we've written down our calculator answer. Now we want to go back and consider all the numbers that went into this final result. Sig figs will be limited by the dimensions of the cube. These numbers went in to generate our volume, so our limit on sig figs is 2. So 2 sig figs, we can write our answer either as 60 decimal point moles, or if we want to write in scientific notation, we can write 6.0 times 10 to the first moles.